Hi everyone, today we're going to be learning about changes in speed. So when we're talking about a change in speed or velocity, we're talking about acceleration. And acceleration specifically is the rate of change in velocity. And because velocity is a vector quantity, we should also be stating it with a direction. The formulas that we have associated with this is average acceleration equals the change in speed over time, or using the symbols A equals V minus U on T. V is the final speed, U is the initial speed, and T is the time taken in seconds. To do a worked example of this, let's say we're looking at a car that speeds up to 60 kilometers per hour from rest in 5 seconds. To calculate the average acceleration, we do A equals V minus U on T. If we're talking in kilometers per hour, we can do acceleration equals 60 minus 0 because it started from rest and it took a total of 5 seconds. This works out to be 12 kilometers per hour every second that it speeds up. So if we look at this car specifically speeding up at 0 times, so at the very beginning it was doing 0 kilometers per hour. If we travel for 1 second, then we have travelled 12 kilometers per hour. 2 seconds we are at 24, 3 seconds at 36. So as you can see, you can calculate the acceleration of the object and therefore the final velocity. In this case, work out the velocity at 4 seconds, 5 seconds, and 6 seconds. The answer should come out to be 48, 60, and 72. A falling object will always accelerate towards Earth because of gravity, and gravity is roughly 9.8 meters per second, which is 36 kilometers per hour. Whilst you fall at great speed, when free falling, your friction will reduce your acceleration, and friction between the air and the falling body is called air resistance. The final velocity reached is called terminal velocity, and we're going to be doing a case study of Felix Baumgartner to determine acceleration due to gravity.